Here we are in the chops chapter for channel operations. So what chops are, they're this sort of elusive, mysterious part of Houdini that allows you to work with animation in some really interesting ways. And a lot of it is it's very similar to animating. I mean, you can see curves, as you'll see as we do this, but we can actually manipulate those curves the way we would almost like an audio program or something like that. And in fact, chops are what we would use if we wanted to bring audio in to do some sort of animation that would be driven by audio. And we could even bring in stuff like MIDI data or just any type of data in general and use it in chops to kind of create some interesting procedural animation. You can do all sorts of other things like adding filtering motion out, adding noises to animation, and even doing things like setting up constraints and whatnot. So while we don't really have time to look at every single aspect of chops, we'll just cover a couple examples that I use a lot in my workflow, and hopefully get somewhat of a sense of what can be done and what the possibilities of chops actually are. So the first thing that we're going to do is create our own jiggle deformer, and we'll create a point level jiggle deformer that we can add to our previous example where we were working with the effector. So in order to do that, I just want to quickly create a digital asset that does the jiggle deformer for us, and then we'll bring it into our other project. So here I am in a brand new scene. I'm just going to save this real quick. All right, so here I am in a brand new scene, and let's just quickly, I'll just make kind of a little quick example to demonstrate that we can apply our jiggle deformer to and see that it's working. So I'm just going to throw down a geo. And we're just going to make some very simple, we're going to make a very simple blend shape operation. So let's throw down a sphere like so. I'm going to switch this from primitive to polygon mode like that. Then I'll just add an extrude. So I'll type poly extrude. I think I grabbed bevel on accident. Let's do poly extrude. And wire this in here. Then I'm just going to extrude all these little faces so that they're sticking out a little bit. So we're going to use individual elements, and we'll just extrude this by a distance of 3. That looks good. And give it some divisions like so. And then let's throw down a subdivide. Let's get this nice and squishy looking. Something like, let's go up to 3 divisions, something like that. And then I'm going to actually, I just want to play with the division size a little, or the number of divisions, just to see if I can get something maybe something like that. That's looking pretty cool. Maybe we'll bring out the let's play extrude. Let's bring this distance out a little bit more and maybe mess with the inset so it kind of bulges out a little bit like that. It's looking cool. And maybe I'm gonna bring back the divisions even more. Maybe something like this. Oops, I want the distance to stay there and make that inset come out just a little bit more. So we sort of have this kind of bulgy looking thing going on. I'll bring that inset back just slightly here. So yeah, we'll go with something like that. Now, in order to do a blend shape, I need to have consistent topology. So in order to make sure I'm staying consistent with my topology, I'm going to just sort of, I'm going to actually create reference copies of these 2 nodes into a separate stream. So I'm just going to right click and actions, create reference copy. So now these 2 poly extrudes and these 2 subdivides are both adhering to the same parameters. But now what I want to do is I just want to break this connection to the distance on this side. So I can delete channels here and extrude this one inwards like so. And I'm also going to break the inset as well. And I know that these 2 parameters aren't going to actually change. These 2 parameters are not going to actually change the point count. So we will have consistent topology that we can blend between. And I can double check this work by middle mouse clicking. You can see here I've got 19,202 points. If I middle mouse click on this one, 19,202 points. So good. I actually want to create something a little bit more on the trypophobia level. So I'm going to actually add some more divisions here. So you can see that even though I'm on this node over here, because it's got this channel reference created by default when we did that create reference copy, I can adjust the divisions over here to get different results. So yeah, that's looking pretty creepy. Let's just, let's see. Maybe I can bring this inset in a little bit more, or maybe change the distance that it's extruding inward. Let's see if I can get this looking, looking a little weird. Oh, what I also want to do over here is I want to add maybe a attribute blur. Attribute blur is going to kind of take this geometry and do something similar to a smooth. I'm going to bring this, let's go back up to the poly extrude and change the divisions to, yeah, maybe 2 divisions, and bring the, bring this extrusion distance inward a little bit more, maybe increase the inset value just a little bit, so this really kind of appears to have a bunch of little divisions in it. I feel like I kind of want a couple more. Yeah, there we go. So I've got on my initial poly extrude, I've got 6 divisions, and that's carrying over here. So on my second poly extrude, I'm extruding it inwards a distance of negative 0.676, and then insetting it by 0.264. And then on this one, what we've got is this extruded looking thing here. I'm going to just I'm going to alt drag my attribute blur over here just to kind of smooth this one out a little bit more. I don't want to go so heavy with the blurring iterations. I'll maybe bring them down a little bit. Yeah, now I'm looking at this, I'm just kind of hoping, I'm kind of wishing that I had this a little bit more, a little bit less divided and a little bit more bulgy like that. So let's look at this one. I'm going to settle for this as a compromise. We're going to blend now between these 2 objects. So we've got this first poly extrude, and these are the settings for the poly extrude. We're going to be subdividing it 3 times and then attribute blurring it with the step size. We can just change, we can set the step size back to the default of 0.5. And then I'm just blurring, the more blurring iterations I have, the more it tries to blur out these distances between these objects. Something like that. I actually want this to be more bulgy, like so. And then, yeah, over here, similar story. I'm going to start with my my poly extrude extruding inward, like so. And then I'm going to subdivide it also 3 times. That's already taken care of. And then my blurring iterations, I'm going to crank those up to like 100 or something like that, just so I get these nice little kind of pock marks in my geo. So I could do a blend shape like so. There's the blend shape node and everything I wire in here. I could just simply, if I highlight this node with these 2 wired in and scroll down here, I got my blend, and I can just blend between the 2 like so. But what I want to do is actually use some more of our VOPS knowledge to actually build a fall off, so we can have this gradually blend from left to right or right to left or something based off of an attribute that we'll use to determine our weight. And how are we going to do that? We're going to do it using our attribute transfer. So let's throw down an attribute transfer. Attrib transfer. Like so, and we're going to transfer. I actually want to go from this shape to this shape. So to keep it straight in my head, I'm actually going to just flip these guys around. I'm going to delete the blend shapes because we don't need that. So I really want our starting point on the left, just because it makes my wiring nice and clean. And the end point, we're not going to be transferring to this. We're not going to be transferring to this geo. We actually want to create like a little fall off. So I'm just going to throw down an add, like we do, and set its value. I'll just enable this checkbox so we can get a point. I'm going to select my manipulator over here and just move the manipulator off to the side. And then we're going to transfer the add attributes onto our main geo and use that weight to drive the point position to change between these two positions. But in order to create a weight blend here, I got to actually create a weight attribute. So let's do an attribute create. Just throw this down, and up here I'll call this weight. And we can see we've got it set to a value of 0. That's good. And then over here we want to set the value of our weight attribute to 1. So I just option drag this over here, changed its value to 1. So now we can transfer that weight. I'm going to untick primitives and select our weight from the points drop down. And then if I go over here, I'm going to bring the distance threshold way down and bring the blend width up to like something like 2. Now if I middle mouse click, or I hit the info button right here and bring that up, you can see I've got a weight attribute here. I'm just going to click this so I can visualize it. And you can see that if I've got my point highlighted right here and I move my point around, it's created this visualizer for us. And you can see that weight falling off in that sort of red, white, and blue sort of way. So if I go to my visualizers here and click edit, you can see that's objects that are closer, that have higher weight, are going to be red, and then it's going to go to white and then blue. So cool. That is working. Now, what I want to do is I'm just going to turn off that visualization for now. Now what I want to do is bring this information into an attribute VOP. So we're going to put down an attribute VOP. Like so. And in our first input, we want our current geometry. And then in our second input, we want to bring in this geo that we're working on over here, which is our alternate position. So if I bring that into the second input here on the VOP, and then we'll just dive inside, and what I can do here is we're going to need 2 attributes in order to get this geometry to transform into that other geometry. So the first attribute we need is the position of our second incoming geometry, and we can get that by importing the point attribute. So I'm going to just type import point attribute, and this allows us to look up a point from our second input. So we're going to wire op input 2 right here into the file section that just tells this thing that it's going to be looking up the input from the file. And then we could also we're going to grab point number, because the point numbers are consistent across the two. They will it will for every point on this object, it's going to look up the position of its corresponding point from the second stream. So now we've got that defined. If I were to wire the result of this into position, it just becomes our other object. So that's cool. So now what we can do is we can just mix between our position and this position. So if I throw down a mix node, and I grab our actual position that we're working on right now, put that back into position like so, and then I grab the resulting imported position like this, and output them, you can see that it's blending between the two. If I drag this slider, we essentially have built our own blend shape. But there's also this bias section right here, and this is where it's cool. We can actually bring in our own weight attribute and determine how we want this shape to fall off. So we bring in our attribute of the weight attribute we created by using a bind, as we have done with any random attributes we create that aren't part of these lists, these globals. And we just want to bring that in. It was called weight, I believe. W-I-G-H-T. Cool. So now we bring this weight, dial it into the bias, and you can see that it has changed how this is acting from, this isn't all acting the same. So if I go back up here to my geo, and I go and grab my add point right here and start moving it around, you can see that it's changing that it's changing the blend shape depending upon where it is, and we can modify this fall off by doing changing our blend width and maybe increasing the distance threshold, stuff like that. So now we move this, add around, we get sort of, we can just get different behavior. So for this example, just briefly, I just want to, let's just maybe just take our add over here, and I will, let's just set a keyframe on its position, and then I'll bring it like maybe down here, like in the middle-ish, but not quite. And maybe we'll set another keyframe there. I actually want to, let's maybe bring let's bring it over here at frame 24, so it kind of has a little bit. Frame 24, yeah, we'll bring it over. Whoops, over here, and then set another keyframe. And again, I'm just holding down Alt and clicking on these parameters to get them to drop keys down for me. So if I play back our animation, it's doing kind of this type of thing. I'm just going to hit the real-time toggle so that it doesn't play back super fast like it does. And we'll go with something like that. Pretty simple, but just should be fun to make this thing jiggle now. So what we want to do now is create a jiggle deformer. And we're going to do that creating a chop net and adding the jiggle node to our points. So it's going to be a point level deformer. So when we move our animation like so, it's going to actually jiggle each individual point as if it were on a spring or something like that. So to create this, we're going to actually create our own little digital asset we can apply to other things. So in order to do that, we create another subnetwork inside of this network that we reference internally. So I'm going to do that by creating a chop net. And this is this is exactly the same once we dive inside. This is basically the same as what we get in. We could build these sort of chop networks in our designated chop motion effects networks area like this. But in our example, we want to actually contain it inside of a SOP. So we can actually build other types of networks out here in our SOP network. So that's what this chop net is. Now we're going to reference a null out here. So I'm going to create that null. This null is going to be called, I'm just going to call this 2 chops, like so. And then inside of our chop net, we're going to reference this null. So let's just dive in there. And I'm going to say I want a geometry node. This is a node that fetches geometry from our SOPNet. You can see that our whole list of nodes is a little bit different here. We can select, we can bring in audio spectrum, stuff like this. There's all sorts of different types of channel operators inside of here that can do all sorts of different things that are much different than the nodes that we get out on the object level. So it's pretty cool. There's a lot of power in here. Gamepad, I mean, audio, just all sorts of fun stuff you can do within Chops. So just know that all those nodes are there, and there's plenty of world to explore inside here. But for our purposes, really what we want to know about is what these different flags do. We've got our output flag, which is really basically after we build our chain, we just want to determine which node is going to be outputting back to our network if it is going to be overriding a parameter or something. And then we've got this display flag, and this display flag actually displays different information in a different section than our actual geo per se. So if I go up here to this motion effects view and I click on this geometry, this display flag, it's going to display a motion graph literally for every single point in my scene, and it can get really slow and laggy if I do that. So I'm not going to do it right now. I can show it in a later example what this display flag looks like. We'll get to that. For right now, all we need to know is that we're going to take this geometry, we're going to apply a jiggle, and then we're just going to export it. So we're going to get in and out of Chops pretty quickly here. So let's throw down a jiggle, like so, and I'm just going to wire this in. Then I'm going to throw down another null, and I'm going to label it so I can find it easily. I'm not going to put the display flag on there. I'm just going to put this output, and we're going to say 2 SOPs. So now if I go back out here, I can throw down a node that can actually look inside of a ChopNet and pull that information and apply it. So I'm going to throw down a channel node. So the channel node is going to look for a chop, and we're going to select that chop in our ChopNet. We're going to select this 2 SOPs null that we created. I'm going to hit accept. So now when I highlight this, nothing's happening. I want to change the method of evaluation to animated because we actually want to have an animated, we want to have an animated result coming out of our ChopNet. I'm going to jump in here and on our geometry also, where it says static, I'm going to set this one to animated. So this geometry is incoming is set to animated, and it is outputting to animated. So now, and I'm getting an error. I'm just going to see what that is. Invalid input chop. Let me just dive back in here. 2 SOPs. Okay. This is named accordingly. I'll hop up here. Let's see what this guy says. Invalid input SOP. Oh, yeah, this is because I haven't actually selected my input SOP either. So I wanted to bring this 2 chops null into my geometry. I never got to do that. So I'm going to pick it here in my 2 chops and hit accept. It's going to think for a second. And let's just get back out here and see what it has done. I'm just going to collapse my tree view like so. And let's hit play. You can see we're getting this nice jello-y, bouncy kind of behavior with our animation now. And that's because on the jiggle, we have all these stiffness parameters we can adjust and affect the damping and whatnot so that we get, either more bounce or less. I can bring this stiffness down, and then we get some really bizarre, really drastic, exaggerated behavior. I'm going to just, for the sake of our exercise here, reset these values back to default so we just get this sort of default jiggle behavior. And then what I want to do is actually create a digital asset out of this. So in order to create this digital asset, there's like one thing that has come up that I found is a little bit of a troubleshooting issue, and I'll show you what it is, and then I'll show you how to fix it. So first off, I'm going to grab these 3 and I'm going to drop them into a subnet like so. Oops. And I'm going to click the back key. Somehow I navigated away. So now our network is contained inside of this subnet. We've got our input here, our ChopNet, blah, blah, blah. It does its thing. It's all self-contained. We want our parameters for our jiggle deformer up here on this top level. So I'm just going to click the gear and say edit parameter interface. I'm going to jump inside the node. I'm going to jump inside the ChopNet, go to the jiggle. So I got my jiggle highlighted here. I'm just going to drag in all these parameters so I can have them easily accessed up top. So flex amount, multiplier, reference. So I get them all. Stiffness, damping, limit, flex amount, multiplier. Yeah, cool. And I hit apply and accept. And then if I jump up here to the to my SOP right here, I can just right click and say create digital asset. And right now I'm not going to rename it. I just want to, because it's going to throw an error. I just want to, explore what that error is and how to get rid of it. So I'm going to hit accept. And then it says the selected subnet has references to nodes outside the subnet or has references that use absolute paths or whatnot. So I'm going to hit cancel because that's not what we want. I'm going to say, okay, it's giving me some warnings that it didn't work, and I can just close this out. So the issue that is occurring is twofold. First off, this channel right here, it is referencing an absolute path. So if we were to create a digital asset somewhere else, suppose we had another piece of geo called sphere, and we're applying this inside of this SOP network. Inside of here, this path would fall apart because it's absolutely because it's an absolute path. It's referencing object geo1, which we're in, and that really only applies to the geometry that we are in right now. So I need to modify this path to use relative references like how we did when we're doing paste and copy relative references in our other networks. So I can modify this And the way I'm going to do is I'm just going to do it by hand. So instead of using this picker to choose our thing, I'm going to delete this all out, and I'm going to start typing. Now, before, when we did relative references, it was ... So if I hit ... you can see that I get all these other nodes that I can access. And you can see that one of them is ChopNet1. I want to go inside ChopNet1, so I'm going to tab down to ChopNet1 and hit enter. And then I know that I want 2 stops. Now, because we have done this with this ... syntax, we know we've got a relative reference, so it won't break if we put this in a different network. It actually knows only to, instead of going all the way back to the root to look for object geo subnet, it knows now that all it has to do is go out of myself, look for the thing next to me called ChopNet, and dive inside there and retrieve my null. So now that that is fixed on this side, we've got another one in here that we have to fix. If you remember, we set an absolute reference here as well. So to undo this, I'm going to just delete that, and then we're going to type it out by hand again. So in this one, we go ... to go up out of this node into this network. And you can see we've got all the nodes in this network, but none of these nodes are the ones that we're actually looking for. We're looking for the null on the network above this one inside subnet. So it's just another ... to get that relative reference. So ... Now we have our list where we can select our 2 chops null right here. So I'm just going to double click that, and that makes our reference is relative now, and it won't break when we put it in a subnet. So now the only other thing that there is to fix is, by default, what happens is if we go to this common tab right here, it changes this export prefix to look up several directories. I'm going to just select all these objects, go to export prefix, right click, and revert to defaults. And see, it just changes it from having 2 slashes to now just ... I'm just going to double check and make sure it updated that for all. Yep, it updated that on the jiggle, and it updated that on the 2 stops. So now, because this is only referencing up two levels, or up 1 level rather, and all these paths are relative references, it should be good to go. So I'm going to go up here, name my subnet something reasonable, like my let's see, my underscore jiggle, and I'm going to right click on it and say create digital asset. And you can see it's got my operator name is Mark my jiggle, so I'll just call it my underscore jiggle, and it's going to be saving it into my OTLs folder and my documents folder. So we're going to say accept, and it's going to bring up the operator window. That's cool, and I'm just going to hit apply and accept. So now that we've got our jiggle deformer as a digital asset, I'm going to just open up a new copy of a new instance of Houdini. If I just go down here and right click and on my Houdini icon and click Houdini ND again, it opens up a new window. So what I want to do now is let's apply this to our other scene that we were working on in our previous example, just to make sure that it's actually working. So I'm going to go and bring that up. Let's go File, Open, Recent Files. I want to use my we're going to use the random effector example from my from the last chapter, and then we're going to make these ripples ripple a little bit more with using our new jiggle deformer. So I want to just save this project as something new and relevant. So I'm going to save it as. I'm going to go to let's go back to our lesson files. We're going to chapter 5A, and I already started doing this in a different project and ran into that glitch and figured out how to fix it. So this is my second take right now. But when I did this before, this is the file name that I used, so I'm just going to overwrite it and hit accept and overwrite. Yep, cool. So save the file in some place that's meaningful to you, or just overwrite your existing file, whatever's good, if you want to do it that way. So here we have our animation. I'm going to just give it a little bit of additional, some additional frames. Let's go and make it maybe 96 frames long, so that by the time, so that it gets to the end of its animation and then it can ripple for like another second. And instead of, applying the jiggle after here to all these cubes, I'm just going to apply it right here to the random effector that is just going to be offsetting these positions. So let's just throw down, we're going to hit tab and type in jiggle. You can see that my jiggle is now appearing here. That's because Houdini knows to look in that OTLs folder and grab your digital asset that you created. So if I click on this, and you can see I actually have made a jiggle for myself prior to this. This is my jiggle deformer that I already had. I just have another one because I was creating it for this lesson. So that's what that's doing there. And I'm just going to drop this in and highlight it, and it's going to think for a second. And we should get some jiggly behavior following our rubber toy. Cool. So we can go, and now that we've got these controls, I can maybe bring the stiffness and the damping down so that our waves are a little bit more drastic after our rubber toy travels through, and you can get something like that. So an important thing to note is that these chop networks can get super heavy and take a while to cook if you've got really heavy geo. If I were to bring the resolution of this grid up super high, it could take quite a bit longer for it to sit there and compute. You just got to keep an eye on this area in your lower left hand corner about how you can just keep track as to whether it's actually doing something, and get sort of a visual feedback as to what it's thinking about. Sometimes when I do this, when I add jiggles to my knitting setups or my weaving setups, it takes, some of them can take like 15 minutes to just figure out what it's going to jiggle. And then eventually it comes around, or it'll crash and run out of memory. So just important to be aware of that you can push it really hard and it'll eventually come through. But if you push it too hard, it probably crash. So that's cool. Now if we go back to our copy to points here, we should get all these cubes kind of doing a little dance after our rubber toy comes swimming through, like so. Sweet. Just to see, just because I'm curious, I want to see what this looks like if I actually apply the jiggle after. So I want to apply the jiggle to all these cubes now that are changing size, and see, how if this wake goes through, I've got these positions jiggling, but I don't have any of that variation in these scales and rotations. But since these are all a bunch of points too, I should be able to jiggle them. So let's just try it. I'm just going to grab this node. I'm going to shake it off, or jiggle it off, if you will. Fitting. And then I'm going to wire this in right here and highlight it. You can see that it's calculating the copied points, fall off, etc. And then now here it is. So now when I play back my geo, I can see I'm getting these waves, but I'm getting sort of some of these cubes are scaling negative, hence why they're turning this blue kind of color. So I want to see if I can get rid of a little bit of that by adding some damping. Maybe to it, or maybe some additional stiffness. So we get a little bit of variety there in our wake, but it's not like too drastic that it's causing our objects to scale in the negative direction. Let's see if I can. Yeah, you can also mess with this limit here to adjust how much it's actually doing its jiggle thing. Maybe just bring the damping down a little bit. Does that help at all? Yeah. So it's a way you can add like a little bit of interest to your animations, for sure. If you have, I like adding these to, like I said, I like adding these to knits, or just anything that looks like it's a little rigid. A lot of times when you're doing some of these like kind of setups, you kind of get some like rigid behavior. I find that using chops and the jiggle will allow you to get like just sort of different, just add some secondary interest to your animations. So I hope that you found this helpful. You now have a jiggle deformer asset that you can reuse in your projects. So I hope that you found this this lesson exciting and helpful, and now you have your own jiggle deformer asset that you can use on any of your projects. So in the next lesson, what we're going to do is we're going to look at other ways that we can use chops to create procedural animation. In particular, we're going to look at motion effects and how to control our animations procedurally using the motion effects editor. So stay tuned for that, and I'll catch you in the next lesson.